Hello and welcome to today's class. In today's class, we are going to be dealing on chain rule method of differentiation. So what is chain rule? Chain rule is a method of differentiation used to differentiate composite functions. Chain rule can also be called function of a function or function of several functions. Alright, so let's take an example. If y is equal to x raised to power 2 minus 5x plus 7 all raised to power 4, and you're asked to differentiate y with respect to x using chain rule method of differentiation, how do you go about it? Our first task here is to write down the chain rule formula. Chain rule formula, which is dy all over dx, is equal to dy all over du multiplied by du all over dx. So this is the chain rule formula. So what's our next task here? Our next task is to identify our u. Alright, so whenever you are asked to differentiate a term, y, and you find out that a couple of terms are enclosed in a bracket, you simply take the couple of terms enclosed in a bracket as your u. So therefore, let u be equal to, what do we have inside the bracket? X raised to power 2 minus 5x plus 7. Alright, so what's our next task? Our next task is to differentiate u with respect to x. So du all over dx is equal to, if you differentiate x raised to power 2, what will you have? X raised to power 2, you multiply x by its power, which is 2, and then subtract 1 from the power of x. So 2 multiply x is 2x. 2 minus 1 is 1. So 2x raised to power 1 is the same thing as 2x. And we have minus here. X here is raised to power 1. So 1 multiplies 5 is 5. You attach x. 1 minus 1 is 0. And according to the zeroth law of indices, any number or base raised to power 0 is 1. So therefore, x raised to power 0 is equal to 1. So x is raised to power 0 here, and it is equal to 1. So 1 multiplied 5 is 5. So therefore, this x is eliminated. Over to this, we have positive 7 here. 7 is a constant because it does not have x attached to it. And if we differentiate a constant, it automatically becomes equal to 0. So 7 is also eliminated. So therefore, du all over dx is equal to 2x minus 5. Let's write it down here. Du all over dx is equal to 2x minus 5. Alright, remember that we took u as all the terms inside the bracket. So since u is equal to all these terms, therefore y is equal to u raised to power 4. Remember, we took u as all the terms inside the bracket. So since u is equal to all these terms inside this bracket, therefore y is equal to u raised to power 4. So we are going to differentiate y with respect to u. So dy all over du is equal to, if you differentiate u raised to power 4, you simply multiply u by its power, which is 4. So we have 4u. and then subtract 1 from the power of u. 4 minus 1 is 3. So we write 3 here. So therefore, dy all over du is equal to 4u raised to power 3. Alright, so what's our next task? Our next task here is to substitute all the parameters gotten into this formula. So if we substitute, dy all over dx becomes equal to, what's dy all over du? Dy all over du is 4u raised to power 3, and then multiply by, what is du all over dx? It is 2x minus 5. Close the bracket. Alright, so what's our next task here? Our next task here is to substitute the value of u. If we substitute the value of u, what are we going to have? Remember that u is equal to all the terms inside this bracket. U is equal to all the terms inside the bracket. So therefore, dy all over dx becomes equal to 4 multiplied by x raised to power 2 minus 5x plus 7, all raised to power, u here is raised to power 3. So we write raised to power 3, and then multiply by 2x minus 5. Alright, let me rewrite it. Dy all over dx is equal to 4 multiplied by x raised to power 2 minus 5x plus 7, and then multiply by 2x minus 5. Alright, so this is our final answer. If you've not subscribed to this channel, kindly subscribe now. And then if you have a question, endeavor to leave your question in the comment section of this video. Ensure you like this video and share it to your friends. See you in our next class.